Hello guys, and welcome to the next lesson. On the last lesson we dealt with curvature and some attribute blur and the scatter density and so on. Create some let me just get this like that. Create some vex so we can define the p-scale. And we will start now to get the p-scale running into, again, a VDB from particles. So VDB from particles. Let me just rearrange that here a little bit. So we'll use our VDB particles here, and of course now it's again way too big. So let's style the voxel size down to 0.001, and of course the point radius scale too, so maybe to 0.00, let's try 85. Did it work? Yeah, that worked good. And I will scale them a little bit up. And the minimum scale and the maximum scale, and of course you can play with the seed. That's fully up to you. Cool. We created that, and now I want to convert that. Just want to convert it back. Of course, what you can use, you can also use some points and just copy that onto them, but we will need later the VDB from particles, because I want to combine that with a newer version or the next iteration with a VDB from particles, and I will need the this like base VDB to recombine that, or VDB combine that. Now we got that, so we got our initial floating points basically. And what I want to do for each point, so we will place down a for each connectivity. For each single point here, for example that point right here, you can press spacebar. You can just press, I think, G, and you will select like the current geometry, or you will frame it in your viewport. And what I want to do on that kind of geometry, I want to scatter over and over again with for each iteration loop, or for each loop with feedback. I want to scatter more points, and we'll do that. So we got our first for each loop, and in this for each loop we will place for each loop with feedback. Just get it in here, and with the for each loop with feedback, we will merge each iteration for sure, and let's just get 2 iterations for the beginning, because it can get heavy pretty quickly. What I want to do, I want to place down a scatter, and I want to scatter a few points, so not 1000. I want to scatter a few points on our geometry, for example 5 points here. And with these 5 points, I want to copy the points, some spheres on them, and then repeat the whole thing. We can just get our create p-scale here. So we will create a different p-scale for that. But first of all, I want to copy 2 points and a sphere. Let's get polygon, and I will dive up the frequency a little bit, and I will then get the uniform scale a little bit smaller, and I will pipe that after before the p-scale. And now what you can see, we will loop back, and we created here our seed, of course, so we will affect the newest iteration, and when we do that over and over again, we will get this little kind of growth effect, or basically we will iterate over and over again and just copy again the sphere. And what I want to do, I want to get here the create metadata import node. And what I want to do, I want to call this meta_iter for iteration. And what I want to do with that, I want to basically get the iteration, the current iteration, to deal with the seed here and maybe also the global seed here. And it's pretty easy. What we need to do, it's go on the little option icon up here and add a spare input. And what we want to do, we'll just drag the meta iteration, or basically the meta node, into the spare input. And now you can see this line here. I think you can get the line with show dependency link for child's node and show dependency links for spare input. So if you disable that, I think you will not see this. I think it's that one. I think it's that or that. Oh yeah, hide. Yeah. So I will choose that, or I basically got it on for show for selected nodes. So when you select the node, you can see with what node the dependency is linked on. That's pretty good for like big networks, if you got multiple loops or multiple sub-based networks. And that's cool, and we created here our spare input. But what we need to do now, we need to import our current iteration into the seed. And it's pretty easy. We will use the detail function for that. And because we created the spare input, we can just type -1. So -1 is the spare input. And then we get iteration. We want the iteration attribute and 0. And now you can see we will get basically a seed based on the iteration. And we can of course copy that into the scatter and get also create also a spare input for the scatter and get that in here. And now you can see that we let's reset. Now you can see that we basically oh, metadata is not cooked. Okay. Let me just delete that. Yeah, because that was the total count, but we need to get it into the global seed, of course. Of course, you can fit it, for example, into the global count and make like a count from 1 to maybe 5 points. That's fully up to you, but I did a little mistake, and it's not, of course, the forced total count, it's the global seed. And you can see when we dialed it up, we will get a really cool little geometry here. So I will leave that to 5. And now what we can do, we can pipe that again into our for each loop, and it will take some time to create that. And the good thing is we can compile this whole loop. So I'll just get here multithread when compiled and multithread when compiled, and I will place it on a compiled block and get a compiled block between those two. And now we can compile the loop. It will need to run one time manually, but after that it will get compiled, and it's pretty fast basically. So now it's done and it will compile, and it's finished. Cool. now we can, I will usually make that black, and now you can see we've got our 12 million points. Of course you can maybe dial that frequency back a little bit, and of course also the force total count, so we can dial that maybe a little bit back to 400 points, and I will then press escape to cancel that. And what I will do, I will just get like a frequency of 4. That will do also the job, because we will create of course a VDB out of that. So VDB from polygons, and that's a good question, what size we should use there. Definitely not 0.1. 0.0005 should do the job. So we will get a good amount of voxels and a good amount of resolution. Yeah, that should do the job. Cool. So this is our little loop setup here. And what I want to do now, I want to basically get the initial VDB from particles back in there. I will use a combine. VDB combine node, and what I will do, get that into the first input and that into the second input, and we will just do a simple SDF union to get the initial sphere in here, so you can see it. We'll get the initial sphere also in there. Cool. So we created that. And now what I want to do, I will go back to our match size, or basically to our out base final. And what I want to do, I want to create also a VDB from polygons. And with this VDB from polygons, we will then subtract the base shape. So we will do this little these organic creations minus the base shape. So go here. We can just copy that here, and this is the A input. This is the B input, but we need to get here a little bit higher resolution. So maybe 0.001, that should be fine. And then we will basically subtract the whole thing. Yeah, no, I will just cancel that out. Yeah, because it tried to combine the whole thing, but we will do SDF difference. And now you can see that we successfully here basically removed the B shape. And what we can do now, we can get this like that and like that, and we can convert it. So convert VDB, and we convert, or can convert that back finally to a polygonal shape. So that's done. Of course you can now maybe we can smooth it a little bit. So place down a smooth node. And we can basically smooth the whole thing, so I will do 50 for now. And I think that should be fine. Of course it will take a little bit of time because it's pretty heavy. So that's done. And now what I want to do, I want to basically create a mask from these surfaces, or these kind of disconnected geometries. And what I want to do, I want to create a mask on our final base tier to get that later in shading. And we can use a mask from geometry, so this kind of node, but it will get pretty slow on this kind of setup, so we will use a attribute transfer for that. And what we can do, a VDB from polygons, so we will get one not so high res geometry down here. So we will just create maybe 0.01 or 0.005. Yeah, that should be it. That should do the job, like 0.0025. And we got our base geometry, so of course we can then just get here the null involved, and we can drag that down here and call this out for mask maybe. And what I want to basically do is to create two simple geometries on each two simple attributes on each separated geometry. So I will convert that back. Convert VDB. Just connect that, go to polygons, and you can see we will get a really rough representation of our geometry. Of course, for final rendering we will use the smooth. You can use that too if you want. And what I want to do, I want to place down 2 times an attribute wrangle. And with the attribute wrangle I will tell this geometry, this is f at mask equals 1. And basically the other attribute wrangle is f at mask equals 0. So really basic, and now we can place down an attribute transfer, connect that to the second input and connect that to the first input. And what we want to transfer basically is not primitives, we only want points, and we want to transfer the mask attribute onto this geometry. And now we can go to the conditions tab, to the distance threshold, and get a really low value, like maybe 0.005. Then we can visualize that, so press on the mask, and now you can see we successfully transferred a mask attribute onto our geometry. So let's template the smooth here. So this is our geometry, and then we can blur that again, attribute blur, and we will blur the mask attribute to let it, just let it fade out basically a little bit, so we can get a better mask for our redshift. So we can transfer the mask as an attribute over to redshift, and then we can work on that with shading. So we got now 2 types of geometries. What I want to do on that one, I want to poly reduce it, and that will take a while. You can do that, so I will poly reduce that just to, like, I don't know, maybe 50% or 30% of the initial poly count. I will just bypass that, and then we will do a quick setup. So I will just do a group delete I will do that all the time because I don't want unnecessary groups, of course. On that kind of geometry there is no group, but I will do it just for the workflow purpose. And then what I want to do, place down a group node, and we can basically create two groups, and with the two groups we can use them later for rendering. So for example, I will call this for group top, I don't know, bubbles, and this kind of geometry will get a different group name, of course. And what I want to call that, maybe group base hue. So both groups are done. We can merge them. We can merge them together. I think that will get pretty heavy for now. Let's have a look. Here, 8 million polygons. And that's okay. Of course, you can on both geometries you can place a poly reduce to reduce them a little bit. After that, the final null basically. So this will be out final. And we've got our geometry built up. So now please experiment with the kind of distribution you want for your base geometry. So experiment with the forces, experiment with the velocity field, and then you can start to build up basically the little shapes on top. And what you can do, of course, you can use other shapes. So don't use a sphere, use for example a platonic solid to get like maybe a mineral build up onto this. Cool, so this is our shape, looks pretty good to me. This is our little subnetwork, and I will see you in the next lesson with shading and look development.